Guys, this video is meant to show how to do both 2 and number 3 on 5.5. Share out of view here. Okay, so I'll start off with number 2, but I'm going to set it up in a very general way because you're going to see that same general way kind of apply again to number 3. On number 2, you have a diver. Coming off of the diving board right there. There they are. Water underneath. Okay, and it says that they are 755 newtons. Now, barring any other expressor, that is going to be the force of gravity. What did I say? 700 and what do we go? 755 there. 5 newtons. The other thing that it says that they have is that the diver drops from a board that is 10 meters above the water. So that's going to be 10 meters to begin with. Then, let's see here. It said find the diver's speed 5 meters above the surface, okay? And then it says before striking the surface itself. So we're dealing with conservation of energy. As I'm doing these problems right now, I'm going to go a little bit, like I told you before, a little bit more general. So it says mechanical energy. So I'm just going to put up all the different types of mechanical energy, gravitational initial, potential gravity initial. Potential elastic initial plus kinetic initial is equal to gravitational final plus elastic final plus kinetic final. Starting off, obviously, there's no elastic in this situation. There's no springs or things acting like springs, so both of these are going to be 0. Next thing that, of course, you want to try to do somewhere in there is figure out where you want your 0 to be. Now, the question is asking right now, part A, how fast they're going at this location, which is 5 meters above. Now, I could be tempted to put the 0 there, but I can also see later on that it's going to ask me the surface. So I'm just going to make the surface of the water 0 joules. Now, I can start canceling. When I start canceling up here, I'm just going to look for, all right, gravitational initial. Does it have gravity initial? Where initially they're up here, right? So I'm going to say, no, absolutely not. Okay, sorry. My apologies. Yes, of course, there's gravitational up there. Is there kinetic up there? No, absolutely not. The person's not moving. They're just sitting there, so that is 0. Gravitational final? Well, it's not at 0. It's up here, so yes, there's going to be that too. And is there kinetic final? Yeah, probably. It's going to be moving. You can imagine a diving situation, and if you didn't know, you could solve it anyway. Now we're going to fill out the individual. Before I fill out the individual equations, I'm going to move this to the other side. It's usually a little bit easier to move algebraically. Before you fill out the individual equations. Now we'll go ahead and fill out the individual equations. That is mass times gravity times height initial minus mass times gravity times height final equals 1/2 mass velocity final squared. Oh, I didn't even notice this before. 2 things. 1, how do I use this 755? Well, 755 is the force of gravity, and the force of gravity is mg. So if I kept mg in here, this would be 755. That being said, pretty sure if I have a mass in every term, the mass is going to cancel. So to find velocity final, I'm going to multiply both sides by 2. GHI minus GHF after canceling the m's, multiply that by 2, square root the whole thing, and that is going to give me velocity final. Now you'll notice that the way that I set this up in variables actually means that I have already solved part B as well. Because by solving part A, I would put initially it's 10 meters, and finally it's 5 meters. For part B, initially it's 10 meters, finally it's 0 meters, and we've solved both answers in that particular way. That's number 2. Number 3 then goes into high jumper, going over high jump. The major difference between these 2 problems is simply this person, the diver, started on top and is diving to the bottom, and here they start on bottom and are going to the top. So I'm going to come back here and I'm just going to get rid of the kinetic energy initial is 0. Still going to leave the elastics as 0 for problem number 3 because yeah, there's no elastic in that situation. Okay. Now I changed number 3 this year. I changed it to be something a little bit different. And so I'm going to talk about the new way of doing that problem, but I'll address kind of the old way of doing it and exactly what I'd expect. The new problem says for part A, it says All right, assume this high jumper jumps straight into the air, and they jump 0.25 meters straight up into the air before they stop. Then you'll notice I put the spot here and here. That's because it talks about the center of mass of the person, which is a little bit above your belly button. Yeah, I think it's a little bit above your belly button, but it does kind of actually depend on the person and very much so also on the gender. Okay, so they're going to jump straight up in the air, 0.25 meters. The question on the old one was how fast do they leave? So that would be how fast are they going at the very beginning. Okay, so they're going to go here. They're going to end up there. So let's go back up to the line. I'm going to see how that kind of changes this part down here simply by this particular setup. For starters, they start on the ground, and I should probably set mine 0 somewhere up here. I'm going to go ahead and set where they start as 0 joules of energy. That means gravitational inertia is 0. So that's going to go away. Just going to erase all this. Are they moving at the beginning? Yes. Otherwise, they're not going to leave the ground. Do they have gravitational at the end? Yes, that's kind of where the energy goes. And do they have kinetic at the end? No, if they're jumping straight up in the air, then it stopped. Now, unlike the last problem, it doesn't tell you anything about their force of gravity or mass. But what you'll notice on the last problem is we didn't actually need to know the force of gravity or the mass in order to solve the problem. So chances are good it's going to be the same here. So I am trying to find the initial speed, which is probably buried in here. 1/2 mass velocity initial squared is equal to mass times gravity times height final. And sure enough, masses once again cancel. We don't need them. Multiply by 2 square root, and you're going to get that whole thing. This is how they expected you to do the old problem. It was expecting you to see that the high jumper would jump up, and we're assuming that they're not moving at the top. Now, the problem with that is that they are, in fact, of course, moving at the top, and that can be kind of confusing. How do you figure that out? So we changed that, and now that makes sense to do part A. And part B says if the person is moving at the top, a horizontal 1.4 meters per second, how fast do they have to leave the ground? Of course, what's going to change here is kinetic final is no longer going to be 0 since they're going to be moving at the top. So we would add 1/2 mass velocity final squared, and notice that since mass is still in every term, it'll still cancel. So to solve for the initial speed, I'm going to have velocity initial is equal to GHF. Sorry, let's finish all this off here. Plus 1/2 mass velocity. Oops, not mass. We already canceled it. Squared. Question is, can I cancel 2? No, because if I multiply everything by 2, I don't have a 1/2 in every term. I can still do that. Like I can cancel 1/2 here, cancel 1/2 here, but I still have to have a 2 on that term right there. Otherwise, it's not accurate. Now we square root the whole thing. The initial equals the square root of 2GH plus VF squared. That does not simplify to plus VF because there's a plus inside that square root. And so we plug everything in here. Let's go ahead and do that. 2 times G times 0.25 meters plus 1.4 meters per second squared, square root. And you should end up, if I'm not mistaken, at 2.61 meters per second. If you had done that without this final velocity, as a matter of fact, you see again that my way of doing this actually serves for both part A and part B. For part A, this would have just been 0, so it would have been 2 times G times H square root, and part A would have ended up as, I think, about 2.21, if you've done it correctly. Hit me up if you still have any questions.